Good morning, good afternoon, good evening. Wherever you are, welcome to the final episode of our series, Graph Hunter Deep Dives. That's right, we're going to get technical today, show you some really interesting and hopefully cool stuff as it relates to graph data science. And so let's jump into it. So I am Corey Summers. I'm Chief Marketing Officer with ArangoDB, and I see a lot of folks that have attended in our prior sessions, so they probably know who you are, Martin.
Hi, Corey. Hi, everybody. My name is Martin. I'm product manager in Cogniware.
All right. So we're going to get into this. We're going to recap episode 3. We're going to get into actually, we're going to show you a really exciting demo on our data science suite. And then Martin is going to take over and do some architectural discussion. A little bit about Cogniware, Martin.
Yeah, so we're a company based in Czech Republic, Central Europe. We provide solutions and professional services for all kinds of different domains, especially law enforcement agencies, intelligence agencies, government bodies, but also for the commercial entities like bank, insurance companies, uh, or any other commercial subjects. And what we are doing, we are trying to focus on the data analytics and investigation part. Now, we do this with our own product portfolio. One of the key products in our line is called Argos. It's the investigation data solution that helps you to analyze the content from whatever types of data sources you have in whatever types of structure of the data. So this is what we are trying to promote. If you can switch to the other slide, please, Corey. I think there is the screenshot, and we already had like 3 sessions. So please go and binge watch all the episodes that we're demonstrating our product. I think it's very, very interesting for people that are trying to find some suspicious behavior of investigated subjects or suspicious relationships in your data. And the solution focuses primarily on 4 stages: analyzing relationships between data, analyzing timelines, so sequences of all the activities, what happened, who was involved, etc. Third dimension is geospatial. So we can visualize the location history of subjects. We can query the map data and see who were the subjects involved in specific places and specific events there. We can also do geocorrelation. So we can trace the co-location history of multiple subjects. We can see which vehicles, people, or any other devices might be together in a similar place in overlapping time. So this is the third dimension. And the fourth dimension, we can analyze multimedia content within our solution. Cool thing is that everything is built on top of one centralized storage, which is ArangoDB for us. So we can leverage ArangoDB to store the source of unstructured content. We definitely store structured data based on our ontology or schema, if you wish. For each client, we have different types of entities, different types of relationships, and we can effectively query. Not query it just simple full text search queries, something like that. We can do the very complex graph traversals. And I was demonstrating quite complex questions, analytical questions last time and in the previous episodes. We will touch the subjects hopefully even today. But I think ArangoDB is providing us the querying capabilities that we require. That's one of the most important things. And we don't even stop there, because I think it was like 1 year ago when we started first thinking about how to leverage it, how to put it to different level. And the large language models and the development in AI actually took our interest. And we were actually pleasantly surprised that ArangoDB is providing also some capabilities in the machine learning and AI part as well. And we started to leverage it. We started with the typical graph analytical tasks. I think the most common is like social network analysis metrics and understand the communities and members of the same groups. But then we were thinking, isn't it time to perform some sort of predictions or anomaly detection over the graph? So this is where we started to play with ArangoDB, and I think it's a cool idea to show some of these capabilities today because they can be like the first point to start interacting with large language models. So Corey, you want to introduce us to the data science suite that Arango is providing?
Yeah, we're going to do that. Before we do that, Martin, I have a couple questions I wanted to ask you. And just so I understand, first of all, Argus in its current form is around investigations, criminal investigations, but this product can be used really for any domain. For example, couldn't you use it for fraud detection in financial or retail, or what could you do there as well?
Thank you for that question. We tailored these episodes around this Jason Bourne idea in investigation criminal sector, right? Because it's fancy. But yes, you can actually leverage it in commercial sector, in any domain where you need to understand your data that involves some sort of relationships. I think this is like the key concept. Just to give you a few examples, you can investigate fraud in, for example, supply chain management. We have very nice use cases, and I was talking about it the previous time, where we have conflict of interest. So large company can issue tender, somebody needs to evaluate this tender, and there are companies applying for that tender or bidding in this tender, and we need to be sure there are no conflicts, there are no hidden interests behind. So these types of investigation or data analytics, if you wish, are definitely like tailored for our product. Argos. So yeah, thank you for that. Yeah, not only the police is involved. I think this should apply to much broader audience, to be honest.
And we want to get into this in a minute, and we're going to talk about our suite. But real quickly, this is the piece of it that is the main evolution of Argus is around natural language and Gen AI. Is that right?
Yeah. So I always say every investigation or data analytics must start with hypotheses or some question that you need to ask the system. So far, we had ArangoDB with all the querying capabilities. We had AQL, and we actually used user interface, or we built user interface that was wrapping those AQLs. So it was easier for non-technical user to interact with the system. Okay, so each subject in our system, and this is like the object in the ArangoDB collection, it has its own overview page where you combine or collect all the information in one place. And you can, for example, for a person, you can see all the relationships to other entities. You can see timeline of events that the person was introduced in. You can see the map, location history for that person. You can see all related multimedia, for example, videos, images, audio files that are mentioning this person. It's nice. The user interface is really intuitive and fine, but to be honest, into the future, we wanted to introduce more conversational style of investigation. Because first of all, this is like the most natural representation of your question is in writing or textual form. And second point is the preparation for the next stage, which would be complete voice interaction with the system. So just to give you some examples here displayed on the screen, like you can profile certain groups of people and you can narrow down a subset of interesting results for you. You can query the details about one specific subject. I showed you last time, I showed you that you can analyze one document and you can actually extract entities from that, and you can expand on the investigation of all the entities extracted from that document. So these types of interaction, we thought it would be really nice to have in virtual assistant using the natural language representation.
That's great. And again, if we look at extending this, you could do it in a fraud use case, and you could say, show me all the or the top fraudulent accounts in Germany in the last 3 hours or the last 5 days, or any combination of question. Once you have the knowledge graph, and that's the beauty of graph rag, and we have sessions on that.
Yeah,
Then
Corey, actually, you raised a very good point, in my opinion, because all these like suspicious patterns of behavior can be detected with typical graph traversal, right? So if you know what is suspicious, you can just simply ask the system. But the thing is that sometimes you need to have some sort of statistical models or heuristics on top of the data, so you can, focus on the less obvious things that are hidden and buried in the vast amounts of data. And I think this is what we struggled for some time, until we found out that actually AringoDB is trying to perform the graph analytics, even in deeper level.
oh, that's great. And again, for all the technical background and some of the demos of Argus in previous episodes, you can go and see a complete demo. You can see, I think it was in the second episode, we had your deep architecture, or fairly deep architecture of how you did this, and the Gen AI aspect of it. But that is a good setup if you look at what has happened, right? Which is, I think, mostly where Argus is, but now you're moving into what will happen. Is that right? Right? Who would be committing crimes, or who might the associates be of this person, or where might they go, right? That kind of thing.
Absolutely. And it has a lot of potential use cases and potential solutions to be applied to. But yes, scoring of the most dangerous types of events and predicting something dangerous may happen, and it can prevent some, very damaging events, potentially save lives. I think this is like one of the key benefits and our, let's say, most prevalent goals that we should focus on. I think we are more than happy to share with you some product sheets or solution white paper, white paper for that. My mail is martin.kovar at cogniware.com. Please let me know if you have any questions. I will follow up with you. We can share materials. We can have any separate call.
Martin thought, hey, we're doing this whole Gen AI piece, but the predictive piece is really, really powerful, what you're looking to do there. And then he's like, hey, why don't you guys show under the covers what you're doing with the whole data science suite and how that is working leading up to the Gen AI piece. So Martin, I think it'd be cool to actually do a deep dive on the AringoDB data science suite. And as we go through that, you can kind of jump in and give us your color commentary. How does that sound?
Sounds perfect, because I think a lot of people on our webinars and people that are watching this, in the recording, I think they have some experience with AringoDB. I think most of the experience is with using AringoDB as the primary storage for data and doing traversals. Now, for us, because we are long-term users of the AringoDB, it was really eye-opener to see all the analytical capabilities on top of that, right? So the analytics, as I've mentioned, social network analysis metrics, and understanding, who is the most influential person in that specific subgroup. What are the peers of that person? So seeing like similar behavior in different people for a specific profile. I think these are hugely important things in terms of the LLM as well, because people are trying to ask the questions that involve that or include that. So who are the most risky people on this watch list in terms of, I don't know, probability to commit some crime, right?
Yeah.
It's just an example, but I think it's really good to see it in action. And maybe I can my experience with that as well.
Yeah. Okay, good. Well, let's get into this. And by the way, graph data science is now kind of the hot new thing in data science. We like to think so. And you're gonna see our approach to graph data science here. What I'll tell you is that we really try to make it simple. We try to make it, obviously, how could graph data science or data science in general be simple? Well, we're trying to help with that and abstract away a lot of the complexity. We do that in a Jupyter notebook because data scientists and other engineers are comfortable and familiar in this environment. So we said to ourselves, why should we recreate the wheel with some fancy interface when we can just basically use the notebook as the roadmap and the guidepost and the fabric that brings all of these capabilities together, that does the orchestration. So that, and the feedback from customers, from partners, has been just incredible on this approach. And what you'll see again is where all this fits together with the Gen AI piece. So what we're going to do in this notebook, we have the major steps of data science. We have our analytics, our graph ML, our Gen AI, and a little bit about the use case. And before we get into that, right, what are the main pieces of our suite? Well, the analytics, right, the graph analytics that Martin was talking about, which are the advanced analysis components, the graph ML, which is personally what I'm super excited about in that predictive mode, and then the Gen AI piece. Now, you could do Gen AI without the others. Typically, before you do graph ML, there's some analytic steps that you'd like to do, as we'll see today. But this can certainly be done on its own, and a lot of our customers are doing the natural language piece through our LangChain integration pack, which makes it absolutely simple to put GraphRag in place with your knowledge graph. But what we're going to do is we're going to look at all of these three things together. Now, our database being multi-model, everything in one data model, not having a separate document database, text search database, geospatial database, right? If you have a graph-only system, you have to use all those other databases in conjunction, and you really can't do GraphML or Gen AI effectively in that mode at all. And so having that single platform is very important.
Corey, I can vouch on that. We tried it multiple times to combine multiple different storages. It's a headache.
Yeah.
You need to replicate the data. You need to cover security parts for that. It's amazing
Right.
tool.
Yeah, and sometimes we hear vendors say, "Oh, we can simulate that, or we can put hooks out and do that." But why would you want to, right? And so, especially with the scalability that you're going to get with Arango. But here are the major steps we're going to do. We've assumed that data is already in ArangoDB in your knowledge graph. We're going to run some analytics to prepare our data for the ML step, which is the really exciting piece. We're going to do our graph ML. So we're going to run our prediction, in this case, to look at fraud. This is a fraud use case. And then we're going to put on top of that new data, our Gen AI natural language interface, which is, again, similar to what we've seen with Cogniware. So here's our fraud scenario. In this case, we're predicting sellers on a retail website, a commerce website, which sellers are promoting and listing counterfeit products. We want to predict that. First, we need to know which products are counterfeit, and that's really what we're going to be focusing on, is predicting when new listings come in, which of those are counterfeit so we can take action. We want to ask that question ultimately in natural language, and we want to do that all without a developer certainly being able to set that up. A developer would set all this up, but every new question would not have to have the intervention. It's all going to be built there for them. And then you can do all these other predictions that you can do. How likely is it a new account will engage in fraud within the first month? Which product categories are most likely to be associated with fraud? So the sky's the limit once you have this set up in terms of understanding the counterfeit product. Then you can do all kinds of other things. So let's take a look at the data model. And again, the beauty of a Jupyter notebook is you can set this up for your data scientists or your users to have all the explanation and guidance here, and you can make quick updates. Whereas if you had an application that you were building for this, you really couldn't make those changes as quickly. And so that's what I love, Martin, about these notebooks, is that they're easily updated, they're flexible, right?
Do you know what I love about that? Because usually it's iterative process. It never goes, perfectly on one go. It needs to have some iterations. You need to have some explanation. In the process, you will find out something is wrong. And Jupyter notebooks are a great way to shape the final solution before just starting, the production ready code. Because it would be not that clever to finalize something in one go and be wrong about some detail.
Right. You know, you can add sections. I know Michael has a lot of experience with these notebooks. You can add, edit, and certainly lock them down. But let's take a look at this data model that we have for this fraud use case. So we have the website in green here. We have our products in red. We have our sellers in yellow. We can see this seller has 3 different products. And then we might have some additional information on the seller. But this is a very simplified representation. Graph's going to be much larger than that, but hopefully this gives you a sense of what we're doing here. And let's look at the actual data that we're looking at for each of these products. In this case, we're taking a look at a counterfeit watch. So this is the actual listing and all its related information. And here we can see we already know that it's counterfeit. And this is our kind of known label. And our true label that we know is counterfeit here. And keep that in mind, right? Keep that in mind, because when we do our model training, our supervised training, we're going to be using what we already know about our data as the foundation for that supervised training as we do our prediction. But this is important just to show you kind of what this data looks like in the system. Now, let's get into really the first step. What we're talking about is the graph analytics. And in this case, ArangoDB comes with dozens of these pre-built graph analytics that you can easily use. We're going to use something called weakly connected components so that we can create some subgraphs. Then we can, the data is more organized or arranged so that the ML routine is not so long running, if you will.
Right, because we usually tailor the graph database structure for our traversal queries. Like we have specific questions and everything needs to be tailored for that. But in this preparation data for some training, we need to have a different shape. And actually, we have a lot of projects where we spend for hundreds of millions of entities and hundreds of millions of relationships. It would be impossible from the performance perspective to utilize the same structure. So I think it's a great concept to prepare the data in better shape.
Yeah. And one other thing about these notebooks, what you're going to see is some Python, some JSON. The beauty is that it's got all the placement of these things in the order that they need to be. And then it's got example code structures that you can easily modify. Obviously, it's not going to write it for you, but it's going to give you that template and that head start to begin with. And then we're going to see some really cool orchestration pieces in a minute. So after we run this, we find that there were 137 subgraphs, the average size 7,000 nodes. And what does that subgraph look like? Well, here's a simplified example. We have this new kind of vertex here, this connection vertex, which is going to basically be the glue that unites all of these things. So we've got our website, we've got our products, we've got our sellers, but now they've been grouped in a way that makes sense so that when we run our GraphML, our node prediction, we're going to be in a much better space to do that in terms of the efficiency of that, the computational power required. And so now that our subgraphs are created, now we can do, and by the way, there's multiple options. Michael, I think you can create the separate subgraphs, or you can append information to the original graph in a way that represents those subgraphs. So you have a lot of flexibility. But here's the fun part, I think, Martin, is the predictive step. You were talking about that. Let's just set a little background here. What do you want to be doing with GraphML? You want to get your data, write some machine learning code, train the model, run the model, and then iterate on that. But the reality is that you're doing something a lot more complex under the covers, right? And I think data science, what we've heard, especially with graph data science, is there's a ton of moving parts that need to be orchestrated. Data scientists are telling us they're spending too much time on this and on this, right? If you look at the workflow, look at all the various technologies that need to be managed and integrated and spun up and spun down, and providing the resources for them. And how do you move the data in between them, right? This is typically a manual and very cumbersome process. And so what we're trying to do with Arango Graph ML is abstract all of that away. And this is an ambitious task, but it's one we've successfully achieved in that we have now this Jupyter notebook you're looking at now. That is the playbook, if you will, that's going to control all of this. Do that through a whole set of Aranga GraphML APIs that we've set up for this explicit process, which will then control the major elements of our GraphML featurization, training, and prediction. And I'm going to get a little technical here. So I'm going to really show you how this all works under the covers. But this is that abstraction away of all this complexity.
Yeah, you can focus on just the data science part, right? You don't need to deal with technology anymore. You just do what you want to achieve with the data. I think that's a great concept, by the way.
Little bit of technology you got to deal with, but a lot less, I would say. We're really excited about this and all the complexity that we're hiding or abstracting away here. All right, so here's our GraphML workflow. We're going to featurize the data. Certainly, we create a project to contain all of this, but the main steps are featurization, training, model selection, and prediction. And I'll go through these relatively quickly, but this is the power of this, where we're going to be able to orchestrate and manage all of this. So featurization, right, for those of you that don't know what that is, we're going to have to take the data that I showed you before, remember that listing, and we need to encode that or create embeddings out of that so that we can have machine readable information that the GraphML neural network will be able to understand and work with, right? We can't use this textual information as the input. So then once we do that, we can run it through our various fraud risk models. We'll ultimately pick the best model, and then we'll be able to do our predictive step. Now you've got to do definition of these feature types. So you've got to actually tell the system, and here we can see that. We're going to define our featurization specification. And remember that information I showed you, that graph, that knowledge graph I showed you on our data? Well, here it is, our products, information on our sellers, our websites, more information on kind of the seller information. And we've defined the feature type here for each one of these. And this is important when we're creating our embeddings so that we can add that specificity in the embedding creation. But this is pretty straightforward, right? And again, the beauty of the notebook is we give you the template and structure for how this should look. Obviously, you're going to define your own featurization spec here. So we do that. And then this is the beauty, folks, of this notebook. It's going to handle all the orchestration, the submitting of the featurization job, waiting for the job to complete. So it's going to give you a monitoring and status of that. It's going to then give you kind of a receipt for the completion of it. And here you can see the details that all of those embeddings were created. And then it's also going to give you kind of a timestamp on when it was submitted, when it started, when it ended. And so again, the power of this notebook to not have you manually do all of this, the operations of this, but it's all controlled through this notebook is really, really neat. And if you think back to the power of this, I know I'm hitting a lot on this, but think about what's required. There's compute resources, there's storage, there's memory that needs to be allocated. And that's going to happen automatically with this based on the requirements. There's going to be containerization that needs to be managed. There's going to be job monitoring that needs to be managed. So there's many facets of this that we're doing with this notebook. All right, so we've got our featurization, and here are the embeddings, right? It gives you some detail on the actual embeddings that were created. And then we have these important embeddings here, fraud X and fraud Y, which are actually the aggregation of all the above embeddings, which will be important. But just to show you, right, what we got out of that embedding step. All right, so now we have we took our human understandable data and converted it to machine understandable data. Now we can get into our model training. And what does that mean? Well, I broke it out here. And again, the beauty of these notebooks, you can put in all this explanatory content so people understand what they're doing. There's model training, and then there's prediction. And we're going to feed the training data, so our supervised training data about the data we already know, which products are counterfeit, which are real. and we're going to allow the model or multiple models in this case to look at patterns. We can tune the models, but here's the key piece. We're going to pick the best model, the most predictive model. And that's what's really powerful about this training step. So if we define the training specification, the input to that will be that featurization job that we did before, right? So that's how simple this is, right? To define the spec, we provide the featurization job result, and we've got our collections defined here. The training job is submitted. So what I'm showing you, by the way, is stuff that's already been run. It was run in the real world. This isn't just screenshots, right? Or this is the real output of this. We submit the training job, we wait for the training job to complete, and then it has completed here. And again, we have the output of all that: submitted, started, ended. So once we put that through, now we can get into model selection. And this is really the key piece here. Is we're going to look at all the trained models, and we're going to look at the model statistics. We're going to then retrieve the best model using what? Test accuracy, right? So that's the criteria we're going to look at. And so here is really the output of that. And this is the model, the best model, 80% accurate. So again, the notebook will handle that. It will run it all through. It'll give you the analysis on the best model. And now we're in a position where we can do our predictive phase. Now, this is where we really visualize the confusion matrix. And for those of you who haven't seen this, they call it that for a reason, right, Martin? It's confusing, but really it's actually simple when you understand it, right? Here's the predicted label as the output of that training job. Here's the true label. And we know a lot of those true labels, obviously. And what we want to see here is a very large number here, and then on through the rest of the data. This diagonal is really what you want to see, the intersection of predicted label and true label. That means we accurately predicted. Now you can see here are true negatives down here in the lower right, and then all around it, you've got your false positives and your false negatives. But these values right here add up to 80% of all the values. And so that's where we get that prediction valuation of 80%.
It's cool that you're covering the whole process of creation of this final model, because in Jupyter Notebook, you can always create some enhancements, right? You don't need to include your solution.
Right. So again, yeah, the generation of these confusion matrices and the analysis of the best model is important. All right, now we have our model. We go down into the prediction phase. So this is where we're going to feed the new listings as they come in potentially or in batch into this ML process. And we're going to generate some new predictions. And just in the interest of time, I'll kind of go through this, right? We define our prediction specification. Again, the same type of thing. Submit the prediction job. And we wait for that prediction job to complete. And then there's the output of that. So what this is then going to do is provide some output for each of those new listings. And it's going to basically predict counterfeit or legitimate. And here we can see that. And let's take a look at a new listing that came in. And here we can see all the information on where it came in, which site, where did it come in from. It's a key fob or a keychain, Toyota. And now we predicted it as counterfeit. And again, we did that supervised training, node prediction, using our graph neural network to be able to do this. And so there's still work to do, clearly, with this notebook, but we've tried to really simplify things. And when our customers have seen this, and some partners have seen this, they're like, wow, this is more complete and more advanced than we've seen in terms of graph ML.
You can generalize, right? You don't need to stick with this counterfeit product, but you can assess contracts, for example, if there are some irregularities regarding that. We have the investigation part. We always start with digital case, right? And digital case combines like multiple different people, objects, location, events, and we can score and assess those cases based on the priority or based on the suspiciousness. So it gives us a lot of opportunities to actually work with graph data, but add something extra. And I think this extra stuff would be useful for the conversation as well, because it enriches your current knowledge, your current
Right.
understanding of data.
Yeah, the sky's the limit on what you're predicting in this case. And there's other GraphML operations you can do other than node prediction. Let's get into the piece that I think is relevant to you specifically. So you again can do this on its own, but you can do it in conjunction with the GraphML. Once you have this data here, you want to provide users with a natural language interface. One of the things that we're really excited about is the LangChain integration pack, which makes it very easy to take a public LLM, your own LLM, and basically do graph RAG right on top of your data. And so once you do some prompt engineering, then you can really the LLM understands your graph. It understands how to generate the AQL, which I'll show you. Here is kind of our own little chatbot that we provide. Obviously, in your case, Martin, you built your own integrated natural language capability, but it's not very different from this, right?
Right, the essence is still the same. You just want to ask a question in natural language. You want to use that question to transform it into the query that we know that is part of your product, and return the results again in nice represented results in natural language.
And so here's the beauty of this is we have our predictions. Now we want to provide a natural language interface and ask the question, who are the sellers most likely to be selling counterfeit products? And then under the covers, we can see this is the graph RAG, folks. And this is where we are basically the LLM, once we do some prompt engineering and do a little training there, it then can generate highly accurate AQL automatically against your knowledge graph. So think about that for a minute. Think how quickly you can get a natural language interface using our LangChain integration pack on top of your knowledge graph. This is a very fast roadmap here. If you didn't want to do all the GraphML, you don't have to. This can be put right on top of your data. And the beauty of this, let's go down to the question. We have all these different questions that you can ask. Once we know counterfeit versus real, look at the type of questions, Martin, we could, I guess in your world, is this guy or person a fraudster or aren't they, or predicted to be? And then you could ask any question here. But if we go down, which person is most known for selling counterfeit products? And so this is really fetch me the person named. There it is, associated with selling the most products that are counterfeit. So once we know the counterfeit products, we can then ask this question. The beauty of this, folks, between graph RAG and vector store RAG is, first of all, you don't have that upfront step of creating vector embeddings, which could be multiple days we've seen to create those embeddings. So you don't need that at all with graph RAG. You also have a very predictable cost model for your queries because you can throttle the JSON here. You can limit that and get a very predictable query cost. Whereas with vector store, you have no idea really as the data grows, what is your cost going to be? So it's very hard to budget and plan for that. And so in many cases also, the cost can be a lot lower with graph RAG, not in all cases, but the key is predictable.
But I think there are like more, let's say, benefits from that. First thing is that I think this is complete mind shift, because until now, it was more technical. People were thinking about AQL and how to type the query. And somehow in the process, they lost the idea why they asked the question in the first place. So now we come back and go to the root, and we really focus on the question rather than on implementation of this question into the query logic. I think it's great because it focuses on the business problem rather than the technological aspects of it. And second thing, which I think for me is very important, is that you answer questions that are coming from your data. They are not coming from the LLM, from the pre-trained knowledge of the model, but these data are coming from AringoDB, from the vetted data source. We can trust the data source, right? Yep. So this is first step to avoid any hallucinations or problems, because what we are doing, we're just querying the data from the known storage.
Yeah, great point. We're going to put a video up shortly on our website that also shows this comparison vector store versus graph, but the completeness of the result is far, far richer with GraphRag, the amount of detail you get back. But what I love about this, first of all, is how quickly you can get to a point where the LLM is generating dynamic AQL automatically, highly accurate on top of your knowledge graph, any question that you want with the extent of that graph that you have. But here's the other thing. This is AQL. What does that mean, folks? That means you can access any part of our model that we support: graph data, document data, full text data, geospatial data, all in one query. So you couldn't even do that with another product that's graph only, because how are you going to on the fly integrate those other components, right? Let's say you have nested JSON as part of your detail on your nodes instead of just a couple labels. This is where the power of that document, full JSON document support, comes in. So this AQL is really powerful. All right, so hopefully this has been valuable for you to see how all this works together. And I think, Martin, what you're saying is you've got the Gen AI piece. Now you're going to be adding, looking at adding the ML. But let's kind of wrap up here. We have about 10 minutes left, Martin, to kind of, let's jump to this.
First of all, Corey, I think it was awesome. I think it was awesome demo to show the core capabilities of the analytics on top of Graph. What we somehow missed so far, you've mentioned GraphRag. Everything you said is 100% true. Like querying Graph in natural language and using AQL in the background to retrieve the result is much more efficient than doing anything else. Maybe for some people during this webinar, it was not unclear how you actually transform the document content into the graph, right? So I think we talked about this last time, but I just want to summarize this example data flow. So imagine you have this paragraph, or it can be long document, or it can be multiple documents. So the first step, what we usually do is we are using large language models to create a graph directly from the text. Just a small tip to kickstart your investigation: you can use the LLM graph transformer from Hugging Face. Again, LLM of your choice. Our solution is LLM vendor agnostic. We're not trying to focus on one specific model, because to be honest, new models are coming every day, every minute, and the capabilities might be significantly different tomorrow than they are today. So we want to do it in a way that it's not tied to any specific model. That's the strategy and philosophy of our solution. So we are using this LangChain LLM graph transformer to create us graph structure. And we are putting these graph transform data into ArangoDB, and then we can utilize the Arango Graph QA chain as the way as Corey was showing you. And then the Arango Graph QA chain automatically just takes the representation of the JSON results and gives you the results in more nicely and understandable way. So this is why we think the vector store versus the GraphRag approach would be much better, more feasible, because it provides you data that can be trusted much more. They come from the AQL. It can use data enrichment, meaning that if you are using typical vector stores on top of documents, you may omit the crucial part from the document, which might be part of your answer. Also, you have no way how to enrich the data, for example, from your current existing collections in Arango. So again, GraphRag gives you much more context into your answers. And it helps you to utilize the context window, by the way, for those that are more technically oriented. The context window is kind of a problem right now for answering questions. And AQL is filtering only those meaningful and important data. GraphRag is definitely the way to go to more trust the data, to have much precise answers. And for most of the queries, it would be actually more performant and more or less costly, I would say. Yeah. And show the comparison. I'm really interested in that video. I think we should follow.
Yeah, it'll be up today or tomorrow. It's really cool. Real quick here, people talk about hallucinations, but one of the things I saw with Vector Store, when you ask the question, it doesn't hallucinate, it gives you a blank stare. And what I mean by blank stare is it doesn't give you any response because it doesn't have that rich context that the knowledge graph has to connect all the data. So if there's a question that includes a word that hasn't been done with the similarity operation in a vector story, didn't make it to that, you're going to get a blank stare. You're going to get no response. So that's another problem that I think you're going to look at. Anyway, real quick, we got to get to some last Q&A, but
Sure.
this is kind of go ahead.
Yeah, I think, Corey, you showed us like, if you look at this picture, this architectural diagram, you have the bottom box, which is ArangoDB. You showed us the ArangoDB data science suite. You showed us Jupyter notebooks, and there are some agents that are already available to any of the audience to interact with LLM. Your LLM are like vendor agnostic as well. So there was this question, which model and what hardware is needed and so on. It really depends on your model that you choose. Some models are very cheap for inference. Some model may be less costly. It depends on. Our philosophy is to have everything on-prem. So we don't use publicly available models. We use always the models that can be on-prem. Now, our approach in Cogniware, and especially in our product Argos, we are not actually using this agent straight away because we feel that's a great way to start with something, but our solution must be really production ready, and there needs to be some countermeasures to maintain the high security standards. So what we are actually doing, we are building our own business logic on top of our APIs because we have already AQLs wrapped with APIs. We have the user interface of our application is really tailored for that question about investigation. And what we did, we created our own agent that can transform the natural language into API call. And there are, let's say, 5 most important things that we have in this custom agents. First of all, we inject ontology. So we tell the large language model how our ArangoDB collection are tied together, what is the meaning behind every entity type or link type. We give information about all the, let's say, attributes or parameters for the data. Now, we use minification techniques to fit the data into the context window. We classify the type of question because Corey showed a lot of different questions. We have typical 4 types of question. Question about relationship, question about timelines or time activity, questions about geospatial view, and question about multimedia. And for each of those, we have different visual representations, existing pages, and different widgets. So we have this classification. We automatically know, based on the query, what type of representation should we use. We store conversational history. Again, there are some hidden techniques which we have in our business logics. And 5th point is very important because it differentiates the policies for different types of customers. There are some custom instructions per every customer, which can be customized, obviously, and there are some standard operational procedures that needs to be followed. In this way, we ensure that the interaction with LLM are, same for all the users across the organization. And of course, we need to have strict security. So you interact only with those data you're able to see because we apply access level controls for the data. So this is the difference. I think, Corey, in the next slide, I summarized it very quickly. So if you want to actually start with Gen AI on top of ArangoDB, I think the ArangoDB data science suite and the agent available on LangChain is a great way to kickstart your project. It's very simple to set up. As Corey suggested, it's just a few lines in your Python code. I think it's a great way to interact with ArangoDB. It's more focused on data scientists or people that are slightly more technical, but it's easy to customize this to any domain of your problem. It requires some coding knowledge, though. What we are trying to do in Cogniware and what I demonstrated on the last episode is the production-ready investigation solution, which is focusing on the end users. Okay, it's ready for specific problems. It's tailored for that problems, and it doesn't require any techniques. Best practices for the typical investigation questions are there. It's straight, ready to use based on your data model, everything, but no coding is required. But it's rather for end user, not the data scientist. It does not allow you to play with the data in that nicely way. What is great, you can combine these two together, right? Because we are using AringoDB, and there is a way how to combine these two worlds together, and for data scientists to allow much more refined features available.
All right, this is great. So there are a bunch of questions. We don't have a ton of time left. Is it just node classification, or are there other models possible? Yes, there are. We actually, just so you know, we have a POC for this. We have a quick start for data science. So if you have an interest in getting this going, we can hold your hand through that process using the quick start, and then we can get into all the particulars of what you're trying to do and what your infrastructure is, or if we need to provide some help with that, we can do that. But I got to tell you, Martin, this is kind of bittersweet for me because this is our fourth and final episode of Graph Hunter. It's had such a great following and a great response. We've had folks really positively engage with this, and I just want to thank you as my partner. I want to thank Marketa on your team. I want to thank Anil on my team and Michael on my team. It's really been a great experience, Martin. I can't thank you enough. And all the recordings are there. So you can binge watch this now if you haven't seen the previous episodes. This has been so much fun, Martin, and I just want to thank you.
I was really engaged. Thank you so much, Corey, for walking us through. And please, guys, just watch the episodes over. We are available anytime for any sort of conversations on our social media. You can engage with me directly on the email. Please follow us, and we're ready to, implement our solutions to your problems.
No, it's been great, Martin. And Argos is incredible, folks. Take a look at it. You can do any use case, any domain in there, but it's just such an elegant solution. All right, with that, we're going to wrap up our show. Again, you can reach out to us using our contact page or through your existing channels that you have. We can sit down with you on data science. You can reach out to Cogniware and they can show you Argos. But it's been a great pleasure, everyone. And that's it. That's a wrap for Graph Hunter.
Thank you so much, guys. Have a nice day. Thank you.